We are live. Could you please chat, tell us something about if we are live? To be true, it's been a few months without doing a live streaming, and we think this is now running, but we are not sure. Hello. We visible and listen. Hello. Hello.
I think it works.
Yeah, I'm waiting. Now running. Okay, thank you. The mysterious brain 3859, wherever you are. Thank you. Hello, community. How are you, Mr. Harsh Mehta?
I'm fine. How are you?
Are you really fine now that we are almost ending Google Summer of Code 2026?
It's crazy.
Crazy times. Thank you. Hello, community. It's been so long on this thing. I don't know. Are you agreeing with it? Do you agree?
Yeah.
Okay. Good. So let's gonna start this. Thank you to the guys that are live on the streaming and are giving us some feedback regarding the video and audio. We hope that this is really visible and audible for now and for the future, because some of you will not be able today to join, but some will see this later. So Harsh, what is the reason we are here today? Explain.
Okay, so we are here for two reasons. First is an announcement, and the second one is an introduction for my project, and in general introduction to Agentic AI, especially for Liquid Galaxy.
Okay, it's going to be an introduction to your project, but not really to your project, but a way to doing the things with the Liquid Galaxy that is new for the future, and that you've been working on it for this Google Summer of Code. At least we are going to make a more general presentation. But first, I want to make an announcement, so please, could you place the slide? And let's see a video. This was from, go to the next slide, please. We have Saumi's face. This was made by student Kabir in the midterm presentation. Thank you, Kabir. And this I think shows up a little bit of what is the status of the AI thing now, of the AI coding engineering, and it's a crazy with the tsunami, as I like to say, the AI tsunami we're having. So today, Harsh, you are going to present us the basis of the project you developed for GSoC. You are still developing because you are still not finished. This is still something like 10 days away. But I wanted to advance this presentation just because I wanted to open, and the senior mentor teams, I wanted to open this to more people to collaborate in the way of using the system you're developing and created skills for this new Liquid Galaxy agentic system. This does not mean that this is going to be the Liquid Galaxy for the future, but I think the future is going there, and we have to take care of this. So, what I wanted to say is this thing is on the screen. We are going to have a new contest. It's a contest, okay? This means that there is something to win, something simple. We will see it in a second. How this works: you attend today's presentation of Harsh, and if you really are interested, send an email to Liquid Galaxy Lab, gmail.com, and say, hey, I'm interested. I am whatever. I live in, I don't know where. I am a student or I work, because this is not related only to the contributors of Google Summer of Code 2026. It's open to everyone in the Liquid Galaxy community. I'm interested on this, and please send me the documentation, and we will send you a piece of document that we have created. Harsh has created next to his mentor Moises Martinez and me, Andrew Ibanez, and I will send you this information. With this information, you get the idea of what we are talking about. Then, from next Monday, I mean, today is Thursday, next Monday, the GitHubs of the different Google Summer of Code projects from this year will be open. And also, you will have access to everything. Means that you can have the full documentation of the project, the GitHub thing, and also this previous document I'm going to send to you. So with this, you read that, and then you have till, let me read the date, I'm advancing it, till September 23, it's 1 month away, more than 1 month away. You have time to recreate a Harsh system and then create skills. This is not code, those are skills for the agentic system we have worked all the summer on the Liquid Galaxy Lab with contributor Harsh and mentor Moises. So again, since Monday, since now till from today till September 3, you can request the work document. We will send it to you. Then you install the document. We will have a part of the Discord channel to talk about specifically about this contest. Let me read this because it was noted, but not Discord channel for this. You have to send the skills in the .md files, GitHub text regular files, to the Google Liquid Galaxy Lab Gmail address, maximum September 23. Also, next to the skill is a text, but you have to send as a .md file, a text file with .md termination. You have to add also in a Google Drive folder a 3-minute video presenting yourself to the camera. Hello, I'm whatever. I have done this. I hope you enjoyed. And if you can record a short video on your system, of course, you need to install a virtual Liquid Galaxy system to run it, because if you don't have it, I mean, you can be creative. You can do the skill, but it will not work if you don't test it. So you have to send this skill. You can present as many skills as you want. We have not put any restriction on this. A short video for every skill, that has to be video for every skill, and please overlay your face on top of your video demo, just because we don't want fake artificial intelligence make videos. Okay. Of course, all the developments you do at all those MD and videos files will be licensed, like everything we do on the Liquid Galaxy. So we will publish them on or if we believe they have enough quality, we will add those to the Harsh project, and of course we will give you attribution of being the creator of the specific skill. And then it's a contest. What is to win? Okay, we will select three persons, 1 skill per person maximum. We will have a jury of senior mentors that will select those. We will send you a swag package of the Liquid Galaxy. This means a lovely shirt, stickers, Flutter stuff, the different kind of swag that we usually have at the Liquid Galaxy. And also we will have an online event that is already published in the inner section of Google Developers Event Platform, starting October 3rd. It was October 3rd, Harsh?
Yeah, October 3rd.
Okay, it's already on our Google Developers Data Event Platform from Google. And in this event, we will present the videos you send us and announce who are the winners. And this will happen early October, because till September 23 you can send the entries to the contest. And one little thing before I pass the word to Harsh for the real presentation. We've been trying all the summer to use Google-based LLMs, and we want, of being an open source community, we want to use the Gemma models because those are the open model source from Google. We use those, but not everybody has the same hardware on their machines to run even smallest Gemma, and usually you need some powerful RTX card or whatever. So we have no obligation. We put no obligation on how you have to use the system. I mean, you can after you read Harsh documentation, you can use whatever you want. It will be nice if you do with Gemma, but if not, you can do it with Gemini on cloud, or you can do any of the hundreds of different LLMs available. A tip: if you use an intelligent, I would say, frontier LLM, you will get frontier results. If you use a poorly short LLM, you will get smaller results. So conseil is use a powerful model to this. The system is open, and you can use any model you want with a standard API connection. So any situation not explained on these simple rules will be judged by us. So this is what I wanted to talk, and why. The reason is because, again, this is something it's happening, and it's gonna be part of the future. We don't know what the future of the Liquid Galaxy is, but we know it's gonna have this kind of experience. Attend, please, next Thursday, 24. No, what is the day? Don't remember. What is the day? We have the demo day. Next Friday, 21, I think. I'm not sure. It's on the Google Developers Platform, also the event. No, it should be. It is. Could you please check, Harsh? This is on Friday 21, the day of the demo day. No, it's on, actually it's on Thursday 20.
I'll check.
I can check because I have many screens there. For the streaming, and if I touch something, I can block the whole streaming. And I understand that we are audible still. Audible and visible. I hope. I never know. So I think the demo day is for August 20. It might be. Harsh.
Yeah. Let me check.
Okay. Let me check too. I see you. Nobody knows.
August 20th.
August 20th, I told you. It's next Thursday, Thursday 20. Okay, so I was saying that please attend next Thursday 20, the demo day, because it will be the day that all the contributors, including Harsh, will explain to you their applications, the developed applications with nice demos developed both in their own virtual machines and also in the JDA Liquid Galaxy Lab headquarters, big Liquid Galaxies demos that are pretty nice and impressive. So Harsh, you can go to the next slide. I will go out of your presentation. I will be there, but with the mics and voice closed, and you can start your presentation. If any moment I want to say something, I go in, okay?
Okay.
Go.
Thank you so much. Even I'm excited to see the different skills that the community will build. So looking forward to that. And with that note, I'll start with the presentation. So first of all, thanks to Mentor Andrew and thanks to Mentor Moises for guiding me with this project and in general helping me understand Agentic AI and how we can use Agentic AI for Liquid Galaxy. So let's begin. We have transitioned a long way. We started in, I think, around 2019 to 2022 was the phase where we had access to chat GPT and other different AI models. But during that time, it was mostly more of just chatting with these agents and getting some kind of response. It started with text, then slowly we had audio output. Now we also have video generation, but the major change that has come in recent years is agentic AI. So we have come from asking AI to telling AI what to do, and the agent will do many things for you. So we'll discuss everything in detail one by one. And the core idea was that instead of us creating code to visualize stuff on Liquid Galaxy, what if we could tell Liquid Galaxy what you want to see, and it will show you something on runtime request. So on that idea, let's first discuss about what is agentic AI. So, like we discussed earlier, that we normally used to just query AI in a chat-based system. We used to ask question and we used to get a response. So the AI gives us an explanation which is useful. It's not bad, but what if instead of asking international dateline explanation, I could tell it that show me what international dateline actually looks like on Earth, and since we have Liquid Galaxy, why not do it on Liquid Galaxy? So to create a KML and push it on Liquid Galaxy connection, and all this manual stuff could be automated with the help of Agentic AI. So, a general definition of agentic AI would be that it is an autonomous system that uses multi-step reasoning and tools to achieve goals independently. It works through continuous cycle of planning, action, learning, and needing to needing constant human prompts. But this is just a definition. You can find multiple definitions. Everybody has a different definition, but the general idea is that a system that can observe its environment, it can reason from that environment, it has the ability to perform some actions, and after that, it can take user feedback and make changes for future actions. So, we'll learn about this in depth in the coming slides. So if somebody is there on chat, you can just put the answer to this. Can you guess the names of these things? You can just write out the orange is something, the blue is something, this girl is something, and the red thing is something. Just write the names if you can do that. And I'll just wait 5 seconds. So I'll come to next slide. I assume at least one of you might have written something. So thank you for that if you have done that. So let's discuss more about agentic AI. A normal LLM make many answers, but the job of a regular LLM, for example, ChatGPT website or Claude website based chat, it will generate text or code based output, or sometimes audio based output for any query that you provide. So it is limited to only that. It is limited to your browser window and a specific form of output to your request. But an AI agent can understand, reason, act, observe, continue, and complete. So, what do I mean by this set of words? Let's understand with the help of an example. So, if I want to see air traffic near India on the Liquid Galaxy, a regular LLM might not be able to satisfy such kind of request, but an AI agent can do this. We'll also understand the relationship of LLMs and AI agents in the coming slides. But to understand this example, an AI agent would understand that a source for aviation data is required to show air traffic. After that, it thinks or it reasons about what kind of data source and tools will be needed to do this. So now it has understanding of the question, it has understanding of, or it has thought of how to accomplish this task. So once it has the plan ready, it will start executing it. So understanding and reasoning is done. Now comes the acting part. It will fetch live data, air traffic data from uh, some kind of tool, and it can use help of some open source APIs like Flight Radar. It is a very popular platform to view air traffic. So there are multiple such sources of information. After we have the data, we have to create a KML to visualize something on Liquid Galaxy. So the acting part has continued to creating a KML, then connecting with the Liquid Galaxy system. It can be your virtual rig or a real Liquid Galaxy. And after that, you have to push that visualizations on the screens, then navigate to that particular place. So these few points were the acting phase, and this is all automatic. I don't have to write a single line of code. I just have to tell it that show me air traffic near India. After that, it will verify the result and report what was found. Maybe I could give a feedback. Oh, that's a great visualization. Or if something was not right, if I wanted to view aeroplanes in orange color, I can give a feedback. And the next time it runs, it will learn from my experience and my feedback, and it will take care of it in the next time. So, a simple definition is that AI agent combines intelligence with the ability to take actions. Now, since I was telling or mentioning LLMs and AI agents again and again, let's understand the relationship of these two. An LLM will provide you reasoning and language understanding. Just like I gave a prompt to show me air traffic on India, this understanding of English text and then the ability to reason is provided by the LLM. An AI agent is something that will use this reasoning skills to achieve some kind of goal. So after that, LLM can process context. By context, I mean the semantic meaning of what you are writing and your conversation about your uh, chats, maybe. Let's understand with this an example. So let's say I was chatting with my LLM about Spain. I want to visit Spain. Can you show me different wonderful places to travel in Spain? And after that, randomly, I just gave it one line that what are the flight prices. Now, if I had started a new chat and asked, oh, what are the flight prices? It will ask me question, what are you talking about? What flight from where? But if it was the same chat, it would give me flight prices of to from India to Spain. And this is because it has context of my previous chats and it understands what I'm asking. And an AI agent, on the other hand, can utilize this and invoke different tools. We'll also look at what exactly tools are, but think of an AI agent as the body and think of LLM as the brain. So AI agent will use a brain, and according to what brain says, it has the ability to perform action. Like move my brain cannot pick my headphones, but my hand can do that. So my brain will tell my hand to pick up the headphone, and I can do that. So LLM is the brain and AI agent is the body. So typical LLM could produce an output for a given input, but AI agents can repeat this cycle in order to perform a more complex task. So this is just the same example that I described. And also, yeah, memory is something which behaves differently with an LLM or an AI agent. So it's just a set of it is a setup architecture that it works on. So we'll look at a very good diagram of what I mean by tool usage, how memory behaves differently with an LLM and an agentic AI system. The main thing to take away from this slide is that LLM is a core component of AI agent. So LLMs and AI agents are not two different things that are competing against each other. It's just that the agent will combine the abilities of LLM and use it to do some more complex tasks. So yeah, now we come to multiple definitions that we'll also look at the future slides. So it's better that you have an idea now. An agentic loop. So it is a repeated cycle of reasoning, acting, and observing. Just like the air traffic example, where it started from reasoning from my prompt, then it thought for how to complete this task, and then it did some action and gave me the output. But a task can be even more complex. Like, let's say I want to view animal migration in Africa. It can happen that there are no fixed sources of data for doing this, so it needs to repeat the cycle in loops. Like, the first cycle will only be to explore web, to search on web, to find different sources of informations, and that was the action which happened, and the output was that I have a list of sources. But my goal is different. I want to see animal migration of, let's say, South African elephants on Liquid Galaxy. So one task is accomplished, but there is a lot more to do. So the cycle repeats. Once I have the list of the sources that I have to consider, I will go on to next task. I will reason on how do I connect to Liquid Galaxy? Am I connect to Liquid Galaxy? Then if I am connected, how do I make the KML? What kind of KML should I make? So if it does not have any idea of creating KMS, it could maybe refer to GitHub and check out Liquid Galaxy documentation. So that would be phase two. Phase three would be consulting me, the user, to ask that, hey, what kind of KMLs would you like to see? Do you want to see an elephant, or do you want to see 3D KMLs, or do you want to look at a path where they came from and where they are heading right now? So it is a set of tasks that it needs to accomplish. So an agentic loop is just a repeated cycle of reasoning, acting, and observing. So, next is tools or actions. It is the capability that an agent can invoke. By agent here, it could be LLM. The LLM is aware of different tools it can use, but to use those tools, you have to invoke them. Like, I have a right hand, I know. My brain knows I have a right hand, but I have to use it also. So some examples with context to Liquid Galaxy could be to run SSH commands or search web for any kind of information. Next, we have skills. Skills are a set of predefined instructions, and they teach the agent how to perform a task. So a skill is just it has a fixed architecture of writing. It has a fixed format of writing. You can write what the skill is about, and all these instructions to accomplish some kind of task. You can just write it once and you can use it again and again, unlimited number of times once the skill is created. And it is just a piece of text. It is kind of a markdown file generally, which is part of your prompt. So your prompt, which, let's come back to the elephant migration. My first input was that I wrote, I want to view elephant migration in South Africa. That is one part. Then the agent will look at the available skills. Let's say it has a skill of animal migration. It has instructions written in that format, in that markdown file, on what kind of KMS to create, what are the sources of data. I have written it once, and every time a user can ask for an elephant migration in South Africa, it will just use that skill again and again. So my prompt is formed with that input text, and the skill is also added with the prompt. Agent here will be the LLM, the brain. It will think of how to do this. It has the instructions, and then it will perform action, which would be to generate KML and then show it on Liquid Galaxy. So for that, you have to Not you, but the agent has to write some code and run some SSH commands. So tools and actions are like the agent's body that perform different kind of tasks, and the skills are an instructions which will tell the agent on how to perform different kind of things. It is just instructions, that's all. Then an important part is memory. So you might have faced this, like LLMs have a context window. If you have a very long conversation, in the beginning you said that, hi, my name is Harsh. It will reply, hey Harsh, good evening, how can I help you today? Let's say you were chatting for around half an hour and the chat is really long, and then you ask, who am I? It will give you some different answer, or it will say, I don't know, or something kind of like that. That is because LLMs do not have unlimited memory. Every model can have only certain amount of memory of its own. But if I have different tools, multiple tools, I have multiple skills, the agent has to be always aware of what things I have. Like if my brain forgets that I have a right hand, then I will never be able to use that right hand. It's a waste, right? And there are multiple instructions that I give to that agent, and that any user could give to the agent, and they log out, they use it after 10 days, they use it for 6 months, and again if they want to use that skill, it all must be persisted somewhere. Like you have hard disks and SSDs to store your information, right? You cannot remember it all, but you have to keep them in a place where you can access that. So memory will store useful information for future interactions. And some examples are remember previous tasks and context. Profiles. So example for profiles could be your laptop profiles. When you want to log in, or a better example is Netflix, because many people uh, know that. So when you open Netflix, you will be asked that who is watching. You can select mom, dad, yourself, or anybody. So every particular profile on Netflix will have its own set of recommendations. Let's say my mom watches some kind of drama series. So when she will go into her profile, she will have recommendations of those kind of shows. And when I log in, um, let's say I watch Marvel stuff. So I will get recommendation of Marvel movies and series. Similarly, even in agents like Hermes that I will talk about, you have things like called profile. Each profile will have its own separate set of skills, its separate set of tools and instructions. It's just that when you use a particular skill, you have a particular profile, sorry, you have access to that profile's skills and information. And if you change the profile, you will change the skills and information that you hold. Gateway. So a gateway is something that connects an agent to your external sources such as Telegram, Discord, WhatsApp, Slack, even Hermes agent that I will talk about. You can give commands to it through either a web application, or you can give it instructions from Telegram, Discord, Slack, everything. It's just a program which will accept, which is first responsible for connection of your app to the agent, and once that is done, it is responsible to accept your messages, perform some actions, and return the output. So we'll talk about all these things in detail with the Hermes agent architecture in future slides. And after that, scheduled tasks. uh, Another name could be cron jobs, which is that if every morning I want to get a report on weather. So I can just write it once, and every day at 8 a.m., when it's the time I ask it to show me the weather report, it will automatically trigger the workflow of fetching the weather and sending it to me, let's say on email. So it's just an agent task to execute something automatically at a defined time. So, since I was mentioning Hermes so many times, let us talk about the Hermes agent. It is an agent framework from news research, and instead of building the entire agent system from scratch. Now, what do I mean by agentic system? So the different skills, tools, memory, and gateways, session management, task scheduling, having multiple profiles. All these things can be made by yourself. Also, you can maybe, let's say, if you are comfortable in Python, you can use Python to write code for doing all these things, accepting or managing connections with Discord, Slack. You can write code for everything, and then you can execute it from those platforms. But Hermes by default provides us a very strong architecture to do all these things. So it is also very popular right now from last few months. So instead of building the entire agent system from scratch, Hermes provides us the runtime to play with, and all you have to do is provide it the brain, because Hermes is kind of the body. The brain is an LLM, and you can it is model agnostic, so you can use any kind of model. You can run, if you have a good hardware, you can run Gemma based models or any other LLMs on your own premises. You can also use any models that are cloud cloud hosted, and you can also switch the models in between. It will handle the complexity for you. So it provides us the agent to it provides us the tools, skills, memories, profiles, gateway sessions, schedule tasks, everything that we talked about in this definitions table. It will perform everything on your behalf. So now let's do a deep dive in the Hermes architecture. The core idea is the same, which is to understand, plan, act, observe, continue. And around this philosophy, in order to first understand, you need to understand the user request, and you need to have some additional context. The additional context could be your skills, your memories. So this is your memory section where it stores a short term and a long term memory. In short, it's just remembering your past interactions and your past requests and your past experience, your feedback, everything is stored in memory. So it gets better the more you use it. And after that, that was for understanding part. You also have a session storage, which is just like the different sessions you have on, for example, chatgpt.com. There are multiple chats. If I can create a new chat and I can again come back to it, or I can create another chat. So the context of those chats is preserved independently. Similarly, it's the same. Every session that you start has its own separate history. You can also continue sessions in Hermes architecture, and that was the understanding part. Let's come to the planning part and the acting part. This is the reasoning part, which is mostly handled by the LLM based on the context from the memories, session storage, the memory of being aware of all the skills that it has. So all those things are then decided by the LLM. It will decide what needs to be performed, and then this performance part is handled by tools, or you can also call them as different actions. For example, doing SSH into Liquid Galaxy to execute certain kind of commands, accessing the file system, maybe to write KMLs or push KMLs, doing an HTTP request. This could be performing a web search. The agent can search for information on web, rendering KML, or adding things in the session storage. That can also be an action. And context compression is something that helps to keep Hermes in limits. For example, the soul.md, it is just a markdown file, and it describes Hermes on who it is, what are its main goals, its personality, and other things. And it has a specific character limit. Let's assume it to be 1,000 characters. So now I am using it for 3 months, 4 months, 6 months, and with me, its memories are also evolving. So it can keep on adding to that particular soul.md file, but there has to be a limit. If it becomes extremely big, it will start to hallucinate and give me different kind of answers or wrong kind of answers. It gets distracted. So in order to keep it in check, context compression happens, which is that when we are about to reach the limit of the memory, you will just summarize everything that was there, and you keep a compact version stored in that particular file. So uh, context construction, coming back, it consists of your system prompt, your skills, your memory, session history, and external data. So these both green boxes cover this region. And then you have tools and actions, and you have skills. Skills are again part of your prompt. And this keeps on repeating and repeating until and unless it has not reached its task or it has been stopped. Then it also has support for cron jobs, triggers, gateway, logging, and monitoring. So we have covered most of this. Logging and monitoring is again to keep a record of things that have happened, maybe some kind of feedback that I gave it, and ask that it is very important that you don't make such mistakes again. For example, the balloon should always be on the rightmost screen and not the left screen or any other screen. And if it is a very important message and it was performing it wrong, it keeps a record of such feedbacks and it keeps it in memory.md. Again, you have skills.md. It creates skills on its own based on your request. And I'll also talk about the architecture that we have for our use case of Liquid Galaxy in a while. Triggers and cron jobs are time-based actions that occur. Let's say, again, come to that 8 a.m. weather example. So those fall under the category of cron jobs and triggers. Then you have support for external APIs and services. It can be any kind of APIs. You need API for weather monitoring or getting the aviation data or some kind of United Nations information on poverty. It could be anything. And this is handled by the gateway, your connection to Telegram, Discord, Slack, and multiple other platforms. And so it will take your requests, it will perform all these loops, and when the output is created, it will send it back to you. And now talking about the architecture that we had, which is that what if a user wants to create their own skill for our project? So I'll show the skills that we have developed right now, and you can extend it. Again, the competition itself, the contest that Mentor Andrew described, is about creating skills. So the architecture of our project is such that when you have to visualize something on Liquid Galaxy, it will first verify with the existing skills. If something related to that is already present, it will use that skill. But if it does not have such kind of capabilities, it will be able to create a new use case for you. So the main goal of the contest is also to have more and more skills. Skills are nothing but just set of instructions written in markdown generally, and you can just add it to your agent and you have something new to do with your project. So again, let's talk more about the skills itself. So this is what makes Hermes interesting. This example is the first skill that we had developed, which is LG SSH control. Now let's take example of chat gpt. If I tell it right now that please connect to my liquid galaxy and perform a reboot, it can, maybe if it's good, if it's a good model, it could give me the instructions to do that, but it cannot perform it. And mostly it might not know how to do that. So in order for Hermes to actually do this on my part, I'll just sit back and watch it do. It has to learn how to connect and how to verify what are the rules to relaunch, reboot, what are the different commands you need to uh, execute to perform some kind of task. How do you control the movement of cameras and the different screens? Uh, all this is described in LGSS control. It is just a set of instructions that teaches the agent to do all these things. After that, you have tools. Tools are capabilities that agent can execute. So, uh, something like writing a shell command via SSH, then handling different APIs that it found on web. So these are not APIs that I paste manually and then tell that in order to fetch data, you have to go to this URL, get some information. It needs to do all this on its own. So there is a web search tool in order to perform a web search and handle the web-based API calls. Browser operations come under that. So for different tasks, you have different kind of skills and tools. After that, you have memory. So Hermes maintains markdown-based memories, and it's all linked together. Like it has an index, and you have multiple markdowns. And the you if you ask something, the LLM will first look at the existing memories, and it will decide that I have something in my memory. I will just use that because it is right. After that, you have profiles in Hermes that I explained, that every profile has its own memory, its own tools, its own skills. So you just switch the profiles to uh, have access to different kind of use cases or different kinds of skills and memories. So this is a note that you must know for our project and the hardware constraints that mentor Andrew also explained in the start. So intelligence of Hermes mainly depends upon the LLM. Like I said, Hermes is just the body. If you give it a bad brain, uh, it will not perform as good as a good brain. If you give it a very good model, we have it in the next slide. It can perform slightly or a lot better. It depends on what you use. But generally, small models don't have a lot of capability like big enterprise models. And due to current hardware limitations, we can restrict development to either these few small models. These are just some options that you can use to run LLMs locally, but the output will not be that great. And we have used mostly some frontier models, so-called frontier models with billions and trillions of parameters. So personally, for this project, DeepSeek 4 has been used, V4 Flash and V4 Pro, and GPT 5.5 was also used at the ADA lab. And when I started the project, I was working with Gemini 3.5 as well. So these give decent or good outputs, and you can choose any kind of LLM as per your capabilities. And it is model agnostic, so it will be aware about the skills. It's just the quality of output that can vary. So how do we use Hermes agent? So Nara here is just a profile that we have created on which runs on Hermes agent, and it has the skills and memories for Liquid Galaxy. It is built using Hermes agent specifically for Liquid Galaxy. Instead of being another chatbot, it can interact with your actual rig. It can create KMLs. It will handle the screen controlling or executing Liquid Galaxy commands through SSH. It can fly to locations. It can visualize multiple types of informations. If something is wrong, it can also help you do that. It can also help you set up your virtual Liquid Galaxy rig, because multiple people in the start of the GSoC season, when they try to set up their own virtual rigs, there are multiple questions and multiple queries that come, and this agent can also handle, or it can at least help you a lot with fixing errors and doing your virtual rig setup. You also voice interactions, so you can give a command in voice. It can also reply in voice, so it's hands-free experience for you. It can use live data sources for multiple things. We'll talk about the use cases in the towards the end almost. And it remembers your particular configurations if you are creating a new skill, which the people participating in the contest will do that. So it will remember your skills. So the goal is that uh, the good skills or multiple new unique skills would be added along with the current existing skills. So this is an example of agent loop with our particular project. Make a KML over Japan and show it on Liquid Galaxy. This is a random query, but it first needs to understand visualization of over Japan, then choose some or be aware first about the different tools and skills. Let's say it has a skill of KML generation. It will load that particular skill as prompt, then a part of the prompt, not the whole prompt, and then create some kind of KML. Let's say 3D polygon. Then use the SSH skill to push it on to the rig. Transfer execution part will transfer that KML to your LG master. Then you can refresh for visualization, and if it's something is wrong, it can also take feedback and perform a relaunch or reboot for you, verify if the operation succeeded, and then respond. So this all can happen on one natural language request. You don't have to write a single line of code for this. So now
This is like
these are a few examples of the testing at Ada Lab of our use cases. And thanks to Mentor Andrew and the team of students at the Ada Lab who made this possible. Let's view at the first one.
what I wanna do for my project. So currently, this is like showing us the endangered species, which is the a bird living in Doñana in Spain, and this is like very complicated because it's gonna call the API red list and then render it. Actually, this is what I'm doing right now for weeks, for months. So you can see now the machine is thinking.
It's a very complicated query.
So now we are flying to the place Doñara. And yeah, as you can see here, so this is the place and with the image of the duck, which is white-headed duck on the red list endangered species. So yeah, it works amazing.
So the query was to show a particular duck and an endangered bird species, and it can reason, it can create KMLs for that. It fetched information about that bird. This was not a particular skill or use case. It was a combination of all of these, and this was all performed autonomously by the agent itself. So now let's look at the second one.
Okay, so here we tried something a little more hard to do and a little more crazy, but it's to put a Pokemon over a place here in Lleida, in the Plaza del Reloj de Balafia.
At certain moment, Harsh, we didn't think this is going to work, but it actually works very well. You're going to see the Pikachu now approaching data. But funny. 1 minute. Okay.
Wait, now we can see the Pikachu on the screen.
We're going to data, to the specific square, and we have Pikachu there.
And it's perfectly centered on the square.
Pikachu. Okay.
So this was the second one about showing a Pikachu at a particular location. So the agent thinks on what to make at runtime, and you don't have to code anything. It will just visualize this for you. Let's look at the third video.
Highlight float zones near Rouen, France. We've taken this example from your documentation.
Yes. Come on.
So here we have the float zones in that city.
So this was about flood zones at a riverbank in France. So it again created this at runtime. So all that we have seen right now is the because of skills. So skills are the secret sauce, and LGSSH control is the skill which can do relaunch, reboot, power off, network checks, KMLs. So a particular request, let's consider the Pikachu request, is is a set of multiple skills, and first it will use KML generator. Once it has the information of what to show, it will create the KML. So the code of KML is created with the help of KML generator skill, and then to add it on Liquid Galaxy, you use the help of LGSSH control. So it's just a set of skills that this agent works on. So in simple terms, skills are like manual or recipe cards that you give it to an AI agent. And while AI already knows how to talk and reason, a skill teaches it a step-by-step way to do a specific job. So instead of me teaching or telling the agent that do this and create this type of code, the color should be XYZ and it should go on LG1. I can write it once and then just keep on sending it again and again for different kind of use cases. So a new capability is equal to a new skill which you can create. We'll talk about the existing skills. So you will have some kind of idea on what different kinds of things you can make with this agent. Before that, let's understand how to set up this particular agent on and the particular profile on your any kind of setup. So I personally used this Raspberry Pi. I hope you can see it. And you can run it on any kind of machine, Windows, Linux, Mac, computer, or Raspberry Pi. It does not matter. It can work on all the systems. But first, you need to understand what is a Hermes backup. A Hermes agent backup is snapshot of your directory. It saves your AI's configurations, your API keys, your custom personalities, and your memory, your skills. So basically, in short, whatever that I have created with the help of Mentor Android Mentor Moises, to transfer it to you, you can either use a backup or you can use a profile export. In short, these both things will transfer all the skills on the current memories from one system to your system. So that's all. It's just like sharing files, and it will have all the skills and use cases that we have developed till now for GSoC. So to set up, uh, we have used the Raspberry Pi 5 and that I showed you. So if you are using something like that or a Linux based environment, you just have to execute this one particular command. You can find all these things on the Hermes documentation also. So just execute this command and it will perform all the or installation for you. There are multiple scripts which will do that. And then you can use this command Hermes import and then part to your zip wherever you have downloaded the backup or the profile export. Both ways are the ones that you can use, and you just write Hermes import and you're done. And use Hermes model to pick an LLM. If everything works or not, to check that, you can write this command Hermes doctor. So it will perform all the checks for you, and if something is wrong, it can fix that. Second way was to run it on Windows. You can use WSL2. It's Windows subsystem for Linux. It is a Linux like environment uh, on your Windows machine. So a bad example will be that you are running a Linux operating system in your terminal. It's not exactly like that, but it will feel exactly like that. So when you install WSL on your Windows, you just have to write this command WSL -d. -d is for the distribution, which in this case is Ubuntu. You can use any distribution, but I have tested this on WSL using Ubuntu and it works. So just again write the same command for the installation script and then import your particular backup or the profile wherever you have. Just add that directory's location. So the commands are technically the same. It's just that one extra setup for WSL. And the third way is using Docker. So Docker is also Docker provides you an isolated runtime to run the Hermes agent. So first create a particular folder and go in that folder. Install Docker using this particular the second command, and just use this command to run the Hermes agent on that particular Docker container that you have just created. It will create the workspace for you, and then once you are inside, again the import command will be used with the particular location of wherever you have your downloaded backup and or profile. So it provides an isolated environment. So even if the Hermes uh, goes rogue, you can protect your system. Mostly that doesn't won't happen, but it depends. So after the setup, in or any way you set it up, when you will start it for the first time and ask ask to perform something related to Liquid Galaxy, it will first check its IP and then ask you some details that it will later save in memory. That is the plan that we had, and I hope it works. So it will ask you your IP address, SSH, username, password, port number, and the number of screens that you have. Just like the settings app, settings screen that you have in the Android apps for Liquid Galaxy. Similarly, it will ask you. So you just have to type this, and it should save it in the memory. So the next time that you log in or start a new chat, it will just take those details for performing different tasks. So now let's talk about the different skills that we have created for till now. And first one is the LGSSS control. I covered this many times. So it's responsible for connection to your Liquid Galaxy rig. It can be any type of rig. And the basic commands like relaunch, reload, reboot, clearing of the cables, powering of the rig can be performed with the help of this skill. This is just an example output. It can be different based on your LLM and your stats. And this is the Hermes based uh, CLI based usage. So you this is running in the terminal. So this is a screenshot from that. Next is the LG use cases skill. Now, if you are a new user and you just logged in and you are just looking at this screen, you don't know what to do. So you can ask, and this skill has context of every different use case that have been developed. currently, and it will just give you some examples of different things it can do, and you can read those and maybe try something out. So these two were more of user experience skills, but the actual use cases are from here. So geography educator, it acts as a geography teacher and visualizes different concepts on your liquid galaxy. So I asked her how river deltas are made. Please teach me. So it has created a KML of some rivers and how this delta is formed in this region. It's the world's largest delta. So these are different. You can ask many different kinds of questions about geography, and this skill will be invoked in order to show that visualization. Then you have armed conflicts. So this particular skill takes information from some open source APIs, and it will show you the different conflicts that are at least reported as per that API, that conflicts are going on. So this is mostly Middle East. Uh, this particular part was Middle East, and these are some African nations which have some conflicts going on. So you can specify it that show me near Europe or in Asia only, and it can visualize such kind of conflicts as KMS on your liquid galaxy. Then you have weather activities. So the weather monitor on liquid galaxy. Here I had given a prompt of asking it to show me how India gets its rains, or will I get rain today. So it showed me the wind direction. These are the southwest monsoon winds, and this blue part is where you have some 1000 of rainfall. So that's about the weather monitor skill. You can ask it anything related to weather. We have next the natural disaster skill. So here I had asked it to show me the wildfires that were going on in Spain, and the natural disaster skill was invoked, and it showed me visually on Liquid Galaxy. The screenshot is compressed, so it looks a bit cluttered, but I hope you get the point. So it shows the spots where the fires are reported, and on the rightmost screen, it has also some written information about these things. So the orange part is contained fires, red are active fires. So it creates all this on runtime dynamically, so it can be a different response for you. Next is live aviation. So it will show you almost live traffic because the information is fetched from API. So it's not real time exactly, but it will show you the air traffic over any region in the world where the information is available. Like you won't see traffic on North Korea because there will be no data about that. So I have asked you to show me air traffic over India. So this was the visualization produced. You can also try it for some other region as per your wish. Then is the history educator skill similar to geography? It will visualize historical concepts or the events that had happened in the past for you and show it to you on Liquid Galaxy. So here I had asked it about the history of Nalanda University. It was a very popular university which was in ancient times in India, and scholars from all over the world used to come and study here. There was also a fire here, which stories burned for multiple years because there were so many books in the university that the fire was on always. This red part is for that mostly, I think. Anyways, so this skill is maritime awareness. It will show you everything related to ocean infrastructure. So we all get internet because of these undersea cables that we have multi-billion-dollar infrastructure. And I just asked it to map those out, especially those coming to India. So incoming gateways are showed here. We have some in Mumbai, Chennai, some coming from Sri Lanka. So these are all the different cables. And then we have energy monitor. it will show you energy infrastructure in the world, like oil pipelines. You have solar infrastructure in deserts. You have huge solar farms or wind farms. Anything related to such infrastructure can be seen with the help of this skill. So you are looking at Russian pipelines that come to Europe, oil pipelines. Next is cyber infrastructure. So all the cyber activities that we know of and that are public are visible using this skill. And these are some cyber attacks. And this particular section is where GPS jamming is reported. So it will change from time to time, but you get the gist of the skill. Internet blockages, gateway protocol anomalies, GPS jammings. Then we have animal migration skill. It will show you where different animals in the animal kingdom have come from and where are they heading to. So this is just generalized visualization. You could ask specifically like the duck that was shown, or the African elephants that I gave an example about, and it will get information for that and show it to you on Liquid Galaxy. Then we have Coral Reef Monitor. You can view the coral reef status using this skill. Coral reefs are something underwater, and this particular request was to show me the coral reefs near the American Sea. So these are some of the skills that have been developed by now, but you can use your imagination to create so many more things. If you have any questions, just let us know. Mostly my presentation is done. There is nothing much that I have to share now. So if you are someone who has been till the end, thanks for watching.
Okay, okay, I'm here. I didn't go away. So we are gonna read the questions we have from contributors. 1 second.
Okay.
One second, I'm changing screens. Here, here, here. Yes, now. Okay, so thank you for the presentation, Harsh. It's been 1 hour plus. Let's start by there are not too much questions, but at least there are a few. And please, contributors, if you have any other question, it's the moment to pour it on the streaming, because if not, it will be not answered. So, they make some kind of guess about what were your logos in the very beginning. They say Cloud Code, Open Cloud, and the third one, which was?
The third one was Codex. Then we had OpenClaw, Cloud Code. So these four. So they are right. Aniket and Trang are right.
Okay. So, Ankit, what is context compression and construction, and how they help to get rid of hallucinations? Try to answer. Nobody one is a total expert, so try to do your best, Harsh. If not, I will help on my own, because I will say I know a bit, but not everything.
Okay. So context compression and construction. Okay. So compression would be to keep everything to the point, and instead of having too much of unnecessary information, we could just have what's important. So that is one way which could help the LLM to stay focused on what is important. And about the construction, I assume context construction. So uh, this would be the result of my request, my input prompt. then the skills which are existing, the past history and the memory of the conversations, and all these things combine to construct a particular context to achieve some tasks. So instead of LLM guessing everything on its own, it takes these inputs, like I mentioned, histories and different memories, to stay trying its best to stay on the point. It helps, but it cannot always guarantee that it will not hallucinate.
Well, you cannot because nobody can, even the creators of the LLMs. But regarding content compression, maybe we can go a little bit because I think no, trans next question is different. So every LLM has a different context window, usually ranging from 250 megabytes to 1 gigabyte. So compression comes with when the memory of your session is full, and then the agent with those is try to understand what is important, what is not important in what you are feeding the context, and then get rid of part of it. So the solution here is very simple. Just try to use models with a large context window. Most of the new ones have 1 million parameters, and this is more than enough to work for a very long sessions. The way we do the session, there are plenty of other more complex sessions that requires more, but with 1 million you do pretty well. Next one from Ankit 2, Harsh, is I think we can connect LG Wiki and Agent will help with problems, I understand. Let me ask this one. Actually, the agent has been trained with the LG Wiki information too. It's one of the many sources we use because it's one of the most important sources of information, of knowledge we have at the Liquid Galaxy. The thing developed with mentors Deb, Siddhar, Josh, Vedan. So as is the most important knowledge base we have already, the agent has been trained with the LG Wiki. So you don't need to connect it because it's already on it. I get also ask, this is for you, Harsh, can we do a storytelling tour with Nara?
Yes, definitely. We can do, and some skills also do this.
I totally agree, and you will see a demo of this on the demo day in the Harsh part of the demo day. Because we have some tours there. Okay, next is from Trang, and latest one. There are not much questions. I hope some other questions are poor. How the agent can differentiate between session, storage, and memory, like long term. When we close a session, which data can be considered as important to be kept and saved in long-term memory? What do you have to say here?
Okay, so I would say that a long-term memory is in the form of markdown files, which the LLM decides based on my conversation what to store in the long-term memory. That all things are stored, and the session history is a separate memory of its own. So the LLM decides to query a particular session for some information. These two things are different, but to store some memory from my session to the main memory or long-term memory, that decision is done by the LLM. If it's deciding something is important, it goes into that but markdown file of long-term memory, or it can also go to your skills as an additional instruction.
I will change a bit your answer because actually I think it's not the LLM that does that, it's the agent.
Okay.
Because it's Hermes, in that case, that learns by itself. So he understands, he or it, we don't know what is that, understands what is this information and stores. If you have, when we are talking about Hermes agent, that is the agent we have used on this project, but there are, I will not say plenty of them, but several other ones. We are focused on Hermes. So actually, when we started the project, this was to be an open cloud project, but finally open cloud has not too much support now, and Hermes was going up and is the most used now. Just a few days ago or yesterday, XAI launched GrokBot. Maybe this will be also nice, but for now and for us and for being open source and really to change the LLM whatever you want, still Hermes is the best, and I hope and I feel that this is going to be for long term. So Hermes decides what is the information it has to keep on memories, and usually when you install the agent, it has a simple memory, but then you can add, if you want, you can switch on long-term memories that Agent Hermes has actually inside, but those are off, those are not running. You just simply start on those long memory, and what Agent Hermes creates, and I think it's already on the backup that Harsh will deliver as their Google Server of Code. It has what they call something like holographic memory. It's some kind of wiki memory based on markdown files, on .md files, that have another level of memory. So this is a long-term memory. Yes, again, I'm trying to explain. This system comes installed already with Hermes, but stop it. You have to run it. You have to say, I want to use this long-term memory. And also you have different providers, something like 5 or 6. You can use free ones, paid ones, local ones, external ones. So we are using, do you remember which one are you using, Harsh?
LLM Wiki.
LLM Wiki. Okay, so LLM Wiki is free on open source, and it works. It's a simple thing. It's a simple skill with .md file that the agent next to the LLM decides what information has to be stored in long-term memory in Wiki MD files, and it stores this. Okay, we will wait a minute for new questions. If not, could you please, Harsh, go to my first slide where I was explaining the contest. I will repeat while we wait. And okay, here. Thank you. So again, where we are waiting for any other last second question, to remember you all that the Liquid Galaxy project is having another contest. This means that you can win something. What you have to do and what days is clearly stated on this slide. If not, you can always send an email to Liquid Galaxy Lab or use the Discord community. And yes, you have to install the system that Harsh has created. First, you have to ask us for the documentation, and then you install this system on your own virtual machine, or you install your own virtual Liquid Galaxy, and then you create a skill. Let's go through in a minute, Harsh, just an estimation. How much time do you think it takes to install your system? For these guys to know, how much?
Can you repeat?
How much time it takes to install your system in an actual Liquid Galaxy rig?
Okay. I think if you are comfortable with executing some commands, it can be done in 5 or 10 minutes.
Exactly. I mean, it's no time, zero time. The only question is to do it in a good way. You need to install it on a separate machine, not a machine where you have all your passwords, your information. It can be a physical machine, or as Harsh has explained, it can be a Docker system inside a Linux or a Windows or a Mac, or it can be in a dual BSL subsystem from Windows or whatever. Harsh has explained at the very beginning that there are options. The question is that, or in this case, Harsh that install in a Liquid Galaxy, in a Raspberry Pi inside a cluster of Liquid Galaxy, virtual Liquid Galaxy, install the agent. So, but the question is that how much it takes. If you have already the virtual Liquid Galaxy, because you are a contributor of the community, it takes minutes, literally minutes. If you don't have a virtual Liquid Galaxy system, it will take, I would say, a couple of hours. Luckily, if you follow the instruction. If you are not lucky, because you didn't read well some information, it will take you more than a few hours. Sometimes it happens with some contributors. So there are no more questions, so we are going to close the session here. Thank you very much, Harsh, for your presentation. I think this is going to be almost the same you're going to do for the demo day, with some surprises, because we have recorded already some some demos of your application, and then nothing more. So thank you, Harsh. Thank you, Mentor Moy,
Thank you so much
for
this opportunity.
mentoring you also, and we'll see you all on demo day next Thursday 20. Bye bye.